Hi, welcome back. By the end of this video, you're going to be able to represent the line in the slope intercept form. Then you're also going to be able to graph the equation of the line given the slope intercept form of that equation. So first, let us, in this case, if you look at case 2 and 4, to get the slope intercept form, we are going to have to do some transformation here. So let us start by number 1 and see how to graph the line in the slope intercept form. So we have the equation of the line, which is given by y equal to 2x minus 1, right? So in general, the slope intercept form is given by y equal to mx plus b, right? So in this case, b is what we call the y-intercept, and how we get b as a y-intercept, if you set x equal to 0 in this equation, you're going to have y equal to b, and this y equal to b is what we call the y-intercept. Now the m which is in this case the m, which is in this case is 2, is what we call the slope, which is the change of y over the change of x. And again, when you have only one number like this, it's the same as saying that you have m equal to 2 over 1, which equal to the change of y over the change of x. And we are going to see for different cases, so this is one, we are going to see for different cases when the change of y is positive or a negative number. So when it's positive, you're going to go up up from the y-intercept, then left, then right from the y-intercept, from the y-intercept extremity. We are going to see how this works. So basically, if the change of y is negative or the change of x is negative, there's some major difference here. But in the specific example, you're going to see how that works. Now, let us jump into that and try to graph it. So in this case, I'm going to use different colors so you can visualize what is going on. So let's pick the red color. Now, if I have my graph this way, this is my graph. So it's the this is the x-axis and this is the y-axis, right? So this is 0, I suppose this is 1, 2, 3, 4, 5, 6. It's not exact, but we can use this as it is. It's approximative, right? Now you first have to graph the y-intercept. In this case, our y-intercept is y equal to, if you set x equal to 0 in this equation, you get y equal to -1. So this is our y-intercept. You set x equal to 0, you get the y-intercept, which is -1. So what we are going to do, you first graph the y-intercept. So this is our y-intercept. So this is -1. Then from that point, this is how it works. Now you're going to go from the y-intercept, which is -1. You go up because the change of y is positive. So this is positive, you go up, right? So you're going to go up, the change of y is positive, so we go up by 2, right? If it was negative, you should go down from the y-intercept. So the change of y, again, the change of y is positive, you go up by 2. Then the change of x, which is in this case 1, is also positive. So you're going to go right by 1. So this is 1. So I will say that this distance is 2 and this distance is 1, right? Now I can just connect these 2 points to make the equation of my line, right? So this is the equation. It's that simple. Now let us pick another example, which is the case of number 2. So in the second case, we have for number 2, we have 3x plus y equal to 1. So in this case, it's not in the y-intercept forms. So what we do, if you subtract -3 on both sides, you're going to get the equation. So if I do some transformation by subtracting -3 on both sides, you're going to get y equal to -3x plus 1. So this indeed is the slope intercept form. Now what is the value of the y-intercept? If I set x equal to 0 here, I get the y equal to 1. So this is my y-intercept. Then the slope, which is m in this case, is negative 3 over 1. So which is the change of y over the change of x. Now it's time to graph. Feel free to pause the video and try to do it by yourself. So you have a graph like this. So this is the y, so this is the x-intercept, the y-axis, and the x-axis, and this is the y-axis. So again, we have 0 here, and as I said, we always start by the y-intercept. So in this case, it's 1. I'm just going to first graph do my graph here. Okay, so this is my graph. It's not exact, again, it's approximative. So I'm going to use the different color here. So you see now the y-intercept again is 1. So this is my y-intercept, so this is 1. Now from that y-intercept, I'm going to go up by no, because look here, this is critical. In this case, the slope, the change of y is negative. In the previous case, it was positive, you went up, but now it's negative. You're going to go down by negative 3. So this is 1, 2, 3, right? We go down by negative 3 from the y-intercept. Then because the change of x is positive, you're going to go right by 1. So this is 1, you go right by 1. So we are here, right? So this is 1, this distance is, so here is 3, but because it was negative, you went down, and this distance is 1, right? And this is the change of y, which is negative 3. The change of x is 1. So we get this point here. Now we can just connect these to that here to get the equation of our line, right? Simple. So this is n, which is the equation of this line. We are done with this case. Now we can pick another example. Let's pick the case of the number 2. If you have number 2, number 3, so we have y equal to negative 3 over 4 x plus 2. So in this case, what we have, if x equal to 0, we have x equal to 0, you have y equal to 2. So this is the y-intercept, right? It's very important. Now the change of m, which is the slope, is equal to negative 3 over 4. So this is the change of y over the change of x, right? Now we can just graph it again. It's very simple. So we have the x-axis here, and the y-axis again is approximative, it's not exact. So this is y. So this is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Then that we have that is approximative again. And then we are going to try to do this graph together. Now again, we start with the y-intercept. So when x equal to 0, y equal to 2, so which is this guy here, which is what we have here. So we are going to have from 0, we go y is 2. So this is, let us use different color. So this is 2. So this is the y-intercept, this is 2. Now because that number is negative, this is negative, right? The change of y is negative, so we are going to go down by 3. So this is 1, 2, 3, right? So this distance is 3, right? But we went down because it was negative, but in this case 4 is positive, so we are going to go right by 4. So this is 1, 2, 3, 4, right? So this is 4. Again, we have this point, then we can connect and graph our line from there, because 2 points are enough to graph the line. So we just have the equation, what I call L prime. This is my line, L prime, right? That's it. It's very simple. Now let us pick another example here. What else we have to do here? If we pick the last case, we have for the fourth case, we have 2x negative 3y equal to 4. So in this case again, we first need to transform it to the slope intercept form because it's not in this case. So we have to make sure y is by himself. So what we can do is we can divide all the equation by 3 first. So if I divide this equation by 3, I'm going to get something like 2x over 3 my negative 3y over 3 equal to 4 over 3, right? But if you extend this, you're going to have 2 third x negative y equal to 4 third, right? So this again, we still need to do further transformation. I have to solve for y here. So I get the y equal to what? I have to, if I add y on both sides, I'm going to have y equal to 2 third x and then negative 3 negative 4 third, right? So because what I did is if I solve for y, so basically I add y on both sides. If I add y, this guy disappear, and then again I subtract negative 4 on both sides. I get this expression. So basically I get y equal to 2 third of x negative 4 third. We just had to graph now. So what this number is approximately 1.3, right? This is 1.3. Now we can just graph it again. Our change in the slope is, in this case, we saw how to get the y-intercept. The y-intercept in this case, y is going to be negative 4 thirds. So this is our y-intercept, and m equal to 2 over 3. So this is the change of y over the change of x. Now we just have to graph it, right? It's very simple. Again, as usual, we just graph this is the x-axis, this is the y-axis, right? This is the x, this is the y, and this is 0. It's approximative again, it's not exact. So the y and the y-intercept negative 4 third, which is approximately 1.3. So I'm just going to assume that the 1.3 is somewhere here. So I use different color. So this is the y-intercept. So it's negative 4 third, which is approximately 1.3. So it's somewhere here. So this is negative 4 third, right? So this is our y-intercept. Now the change of y is 2. So this is positive, so we go up by 2. So let me write this down this side so make it clear. So this is negative 4 third. So the change of y is 2, so we go up by 2. This is, so in this case it's a little bit tricky, so you have to measure it. This is 1, you go up, this is 1, and then the 2 is going to be a little bit somewhere here, right? You have to measure it a little bit. So we go up by 2. So this distance, you have to make sure that this distance is 2, right? So we went up by 2, and then we are going to go right by 3, right? So we go right by 3, 1, 2, 3, right? So we get this. Again, we can connect this point and get the equation of our line, right? So this is our equation. So that's it for this video. So that was how to graph the line in the slope intercept form, and also we also saw how to transform the equation of the line to the slope intercept form. Thank you.